Good morning. No, it's not morning anymore. Good afternoon, everyone. Good lunchtime. I hope everyone has had a good day so far. We've got an exciting lecture today, and hopefully you will learn quite a bit from today, but also I plan to do a few things that will be useful for your assignment, and I will let you know, the deletion thing will be useful for your assignment, but also something else that I do today will be useful for the assignment. And I will let you know when I am doing something that is relevant for the assignment. Okay, so let's get started today. All right, so yesterday we talked about inserting into a linked list anywhere, and we talked about searching through a linked list to find where we should insert. And we're going to do a little bit more of that today. So I'm not going to talk about it in too much detail because we'll do a bit more insertion today. But that searching through the linked list for specific conditions is also going to be pretty useful to us today, because today we're going to be deleting from a linked list. And we're going to talk about all those boundary conditions that we kind of started talking about yesterday. And we are going to talk about those today in more detail so that you get to see and get to know where the different boundaries are. What is it that we need to consider when we're playing around with a linked list? And again, I can't say it enough, but the best way to figure out if something is going to go wrong with your linked list is to draw it as just a series of squares that are linked to each other. So draw it as a diagram. And based on that, you'll straight away be able to see what are my boundary conditions, where will it stuff me up, and you can deal with it accordingly. And we're going to do that today. In particular, when we're doing deletion, we're going to look at all the things that can go a bit astray, and we're going to, make sure that we deal with those things before they go astray. So we're going to take care of them. Lecture code today is inside the Week 8 directory, although I'm about to go to do the World Cup prep code again, because I'm going to do a few more insertions in there under different conditions. So that one is in week 7. So in the week 7 directory, that one. Okay, let's go. Let me switch over to the code, and we'll talk about what we did yesterday and what we will do today. I think Jess has the buffering bars. Am I buffering? I shouldn't be buffering. It's telling me stream is healthy. You wouldn't believe how much I'm paying for the internet starting last week to make sure that I don't time out and conk out of this lecture. Please let me know if I am buffering or if everything is going okay. And Tom Killingback is in the chat. He will be, okay, excellent. It's all okay, good. I started sweating a little bit because I was like, no, it cannot time out. There's no better internet I can go to. This is it. This is the height of where I can go. Okay, fantastic. So let's get going on our code that we were doing from yesterday. All right, so yesterday we talked about, before we went away, when we finished our lecture, we talked about inserting into the linked list after a particular node. Okay, so, okay, Jess was just testing YouTube emojis. Okay, that makes me feel better. I got a bit stressed that you were buffering. Okay, good, excellent. All right, and we kind of said, okay, let's try and insert after a particular node. So if we insert after, I want to insert Spain, and Spain has scored 6 goals, and I'm giving it the list into which I want to insert it into. So in this case, I made this function I'm not passing on what I want to insert after. I'm just going to deal with it in my function. But that is also, I guess, depending how you're solving this problem, you can also choose to pass that input with your function, what you would like to insert into. So let's say I want to insert Spain after, I don't know, where would you like to insert it? Where should we insert it? Where should we insert it? We've got Australia, France, Mexico, Argentina, Brazil. Who wants to insert it where? And I'll go through the process in the diagram, and then we'll solve it in the code. I don't know, should we insert it after France? Let's insert it after France. Okay, so let's say I want to insert after France, which means that I want to insert it in here. I said France last lecture. Oh, look at this. And I said France this lecture. Thank you. Thank you for that reminder. So I'm going to insert it after France in here. I've drawn you a much better diagram so it's not as confusing with all my handwritten stuff in there. So if I'm inserting in here, first of all, I need to actually create the node that I'm going to insert. So I'm going to use malloc to make up my struct, and I'm going to make this new team pointer, which is going to hold the address of whatever it is that I create here. So let's say I've malloc some space and I've created it, and I'm going to put the pointer to this memory in this new team pointer. And I'm going to create it as a struct team, which means that it will create for me this empty struct. Okay, so if I'm passing to my function, I pass to it Spain and I pass to it 6, that means I'm going to load it up with, I'm going to initialize this struct as well. So I'm going to initialize the name of the country to Spain and the goal numbers to 6. And then this is just going to be null because I'm going to create a new node. So I'm going to use my create node function to create it. And then I want to actually insert it. So what has to happen? Okay, I'm going to first start my current counter at the head of my list, and it's the list that I'm passing to my function. So I know that this head is the list I'm going to traverse through. So I'm going to set the current pointer to the head, and what I'm going to do is I'm going to go across and I'm going to keep going until I find a node that has the words France in it. Okay, who remembers what function I can use to see if the word says France? So pop it in the chat when you remember. Once we find this node that has France in it, I want to stop there. And what I want to do is I want to insert after it. Now what that means is I'm going to take this next address here, and instead of it pointing to the node that came after it in the old list, I want to point it to this node here. So I'm going to point my current node to the new node that I've created, and I'm going to point my new node that I've created to whatever the current next was. So whatever was in here, that's what I want to put into my current next. And quite a few said strcmp, fantastic. Now we're going to use string compare twice today. I'm going to use it first to find the exact match of the node. And if I want an exact match, then string compare, who remembers what string compare returns if I want an exact match? Okay, I'm going to leave that whilst you answer in the chat because I think there is a slight delay with me. Yep, Theo, well done. So string compare will return 0 if it's an exact match. So let's take the actions that, well done. You are all so on top of it. Let's now take the exact actions that I've kind of described when I was drawing my linked list and put them into code. So first of all, let's set our current to the head. So I'm going to create a struct node current pointer, and I'm going to set it to the head of my list. So what that means is whatever's inside the head, the address, that's now inside my current as well, which means that current is the one that I can modify, but my head will still be pointing to the head of the list. Okay, so now I want to be actually able to create this struct with Spain in it. Okay, so what I'll do then is I'm going to have a struct team, and I'm going to create a pointer to a new team, which is what I've called this pointer here when I create a new one. And I'm going to use my create node. No, I think I called it create team, sorry. Nope, so create team. So I'm going to use my create team function, which will allow me to actually create this structure here and return a pointer to where on earth it's been created. So I'm going to create the team, and what will I send it? I'm sending it the name of the country. So I'm sending it Spain. So I can either say Spain here, or actually, because I've actually sent the name of the country in here. So I can just say, okay, create the team with just country, which is where I've stored it. And what else am I sending it? I'm sending it the number of goals, which is and then I'm giving it the new next, well, I just want to create an empty one, so I'm giving it a null. Okay, so that will create this node for me, okay? And this node will then be loaded up with Spain, 6, and null. So it will just be this empty node, and the address of this node that's just hanging out without being connected to anything is located inside this new team pointer. Fantastic. So now I want to go all the way to, you know, the one that matches me. So I'm going to search through the list. Where do you think I should stop? Should I go through the whole list, or should I stop at the second last one? Should it be current? What do you reckon it should be here? So I'm not finishing this until someone pops in the chat. So what do you reckon should be my condition for searching? Yep, so until current is not equal to null. So that means that it will take me all the way to the end of that list. And that will be because I want to know, I want to see that it's not going to get, I want to see if this one also matches. So I want to go all the way to the end of this list. So I'm going to say current is not, and again, we're going to see a better application of when we should search for current next is equal to null in a bit. And then we said we're going to use a string compare to compare our two strings. So what am I comparing? I'm going to compare what is sitting inside my current and inside the country. Yeah. So I'm going to compare what is sitting inside my current in the country member. So I'm going to access that. And I want to compare it to whatever I want to insert it after. So let's say we're doing it France. Did I spell current wrong? I have spelled current wrong. Thank you very much. That would have been a fun compiler error. Okay, excellent. Good pickup. So we're comparing these, and I'm saying if this comparison is going to be equal to 0, which means that they are exactly the same, that means I have, yes. Well, no, it's not Spain, because Spain is what I'm inserting. But I'm inserting it after France. So this is comparing, I want to find a node with France, find a node that has France as the country, and insert after it. So that's why I'm comparing whatever's in my current country, and I'm comparing it to France. Okay, so if that is correct, then I want to insert it. And we have said that what happens then is this, when I was describing it, I went that I changed this pointer to point to this one, and then this one to point to this one. But really, if I do that, what that means, if I just change this one straight away, I'm not going to know, I'm going to lose track of this node. I'm not going to have an address to it. So first of all, I really need to put whatever the address is in here into my new node, because otherwise I'm going to lose it. So my new team, the next of my new team, which is currently null, I wanted to point to whatever France was pointing to before, because I'm inserting after it. So I'm going to point it to whatever is inside my current and whatever is inside the next address. And then I can change my current next. So then I'm ready to change this one here, and I can change it to point to my new node. And the address of my new node is inside this new team pointer. So new team pointer. Okay, and then of course we have to increment so that we don't get stuck in a infinite loop. So I'm going to say current is equal to current next, which will increment me to the next node. So that's what will keep me going from one to the next. And then I will return the head of the list. So let's see what that does now. Actually, did I insert it in my main? Let's just check. Yeah, okay, let's see what it does. I really do the longest file names. I really just need to make much shorter file names. Okay, so I have got a whole bunch of errors. Let's see what's happening here. Okay, so starting from the first one, so remember how we we start from the first one, incompatible pointer type initializing struct node. Okay, so what did I do here? What line was it on? Let me have a look. Line 74. Oh, I know where it was. No, it wasn't. Line 74. Oh, yeah. Okay. No one knows what node is. Thank you. Good. Excellent. It's called node. Yep. Good. See, this is, let me just check that all the rest of them are not nodes. Oh, well, there we go. Perfection. Yep. Okay. And if we run it now, we'll have Brazil, Argentina, Mexico, France, and Australia, which is the first lot. And then it's printing them again, but this time it's inserted Spain after France. So that's exactly where I wanted to insert it. Okay, so then that's inserting after something. Okay, now that was inserting after a particular node. So again, you just search for the node that you want. You compare it, the strings if you need it. If it's a string, you compare ints if it's an int, and then you can insert it as you need to. Now, what happens if we want to insert in alphabetical order? Okay, and this is something that's going to be useful for your assignment. So what I'll do first is I'll actually change these to be in alphabetical order, and then we're going to insert something in alphabetical order into them. So who's first? Argentina. Then we have Australia, Brazil, France, I'm going to go with Uruguay. Okay, so let's say I want to insert, what should we insert? Who should we insert in here? Who wants to insert which country? Madagascar. I don't know if I've ever seen. Okay, let's do it. Okay, we're going to insert Madagascar because that was the first person to the fray. Okay, and Madagascar is going to score, I don't know, 1 goal, and we're going to give the head of the list. Okay, some good suggestions. So let's do this function that will insert alphabetically. And what we have is going to be something very similar to this, but slightly different, okay? So how is it going to be different? What can you use to find whether or not alphabetically it makes sense? Well, alphabetically it's going to compare. So let me erase this and then we'll do our new comparison. Okay, so we can still use string compare. Okay, and let me, yeah, that's not bad, Lisa. There is a simpler way to do it. Okay, so that's a great idea. That's really what string compare at some stage does. So the way string compare works, let me just go through it with you because so far we've just said if it's equal, then it's going to return 0. Okay, what if it's not equal? Let's say I'm doing string compare and I'm comparing Jax and I'm comparing it with Juno. Okay, so I'm calling string compare out, and what string compare does, it says, okay, let's say this is string 1 and this is string 2. What it will do is it will say, okay, I'm going to take the first character of this and I'm going to take the first character of this and I'm going to compare them. Okay, these two match. So I'm going to take the next character of this and the next character of this one. These two do not match. Which one is bigger, A or U? And think about it, you know, on your ASCII table, they all have numerical values. So, but even besides that, the letters are still in order. So which one is bigger, the A or the U? Okay, So U is the bigger one. I mean, I don't know why I waited for an answer to this question. It's obvious that U is the bigger letter. So U is the bigger letter, which means that it's going to return that it's less than 0, okay? Now, if I decided to go backwards, so if I did string compare, and I was comparing Juno with Jax, okay, I'd have string 1 and string 2. So it'll take the J's, it'll say, okay, those are equal. Then it'll take a U, and here it will take an A. And now it's going to go the opposite way because the U is still greater. So what it's going to return is it's going to return that it's greater than 0. So it's really based on where it's going to compare. Oh, my face cam's in the way. Thank you for letting me know. Oh, and it's right where we would want it to be, where I want you to look. Here we go. There we go. Okay, so we have string compare Jax and Juno, and it will compare letter by letter. In this case, if I've got Jax as first, the A is greater than the U, which means that it will return less than 0, and it's going to point in the direction. And if I change them around over here, like I've done over here, then the U is going to be greater than the A. So string 1 is going to be greater, and that means it's going to return greater than 0. And you know what I'm going to do? I'm going to write down the rules over here because you are going to use it in your assignment. It's going to be a super handy thing to know what string compare does and how it can make your life a lot easier. Okay, I'm going to move my face cam again. I'm going to pop it here for now. Let me know if it's in the way again, and I will move it again. Okay, so I'm just going to make some notes here that you can always access for string compare. All right, string compare, it returns 0 if the two strings are identical. Excellent, we've got that. Now it will return greater than 0 if the first non-matching character is greater than that of the second string, and it will return less than 0 if the first non-matching character is less than that of the second string. Okay, so that's something that we can use to compare alphabetically where to find the insertion point, because it compares not just the first letter, it compares them character by character and will tell us what's going on there. And that will give us a bit of a hint of how to insert. So if we're inserting Madagascar, and I just can't, all I think about when I say Madagascar is the cartoon. But if we're inserting Madagascar, and actually let me just rearrange these in the alphabetical order so that it is exactly what we want them to be. Okay, so okay, so what are our countries? They are, well, now Spain is going to be, I'm just going to comment this out for a second, otherwise Spain is going to throw us. Okay, so we've got Uruguay, then we have France, then we have Brazil, then we have Australia, and we have Argentina. Okay, so we know that we want to insert. Well, it's going to be here again, isn't it? Because M comes after F, and so in the same way that I was doing it before, I'm going to actually do create a current, which is going to take me to the head of the list so that I can go through and search and compare each node over. Then I need to create my node, so I need to malloc some space, and I'm going to store the pointer to this new node that I create in new team. And my node is going to have Madagascar in it. And how many goals did I say it's going to have? It's going to have 1 goal, and I want to just create a basic pointer that's going to just have nothing in it yet. So then new team pointer is going to store the address of this new memory that I've just allocated. Okay, so what happens then? Okay, then I need to go through each one and compare the 2 strings. So what I'm going to do is I'm going to compare the string from Argentina, the string from that first node, with the name that I've given that I want to insert. Then I'm going to go, if it's alphabetically doesn't come in, then I'm going to keep going. What do you think is going to need to be the condition? Where I'll insert it alphabetically? What do you reckon? Which one has to be, what does it have to return? Does it have to return 0? Will it return more than 0 or less than 0? Which one will it return if I want to insert it alphabetically? Okay, so I'll let you think about that, and you can let me know what you think about that. Yeah, so you're saying less than, because it depends which position I'm going to put them in, yeah? So remember, because it's based on where the first string and the second string. So if I'm comparing Argentina and Madagascar, I want it to be that the M has to be in there. Yeah, exactly. So it depends in which order I'm doing each one in. Exactly, well done. So it depends on the order in which I'm going to compare the strings, because it's comparing string 1 and string 2. And what I want to do is I want it to be this way. So I want to be it depends again. So let's have a look. Let's start writing, and then we can see which way we're going to do it based on how we define our function as well. So let's do insert alphabetical as our function. Okay, so insert alphabetical, what's it going to return? Is it going to return something? And what are we giving it? So we're giving it something here. You can see what we're giving it. I'm giving it a country, I'm giving it number of goals, and I'm giving it the head. And yeah, it's going to return the head. So it's going to return a struct. I keep saying team, sorry, because I'm used to doing broad nodes. So we're going to return a struct team pointer because it's going to be the head that we're going to return. It's going to be called insert alphabetical, and we're really going to give it the same things that we give insert after. We're going to give it the country that we want to insert alphabetically. We're going to give it the number of goals, and we're going to give it the head of the list that we want to insert into. So I'm going to copy that across, and then let's copy that and bring it down to here. Okay, so let's do that. Okay, and someone said already that I'm going to return the head, so I'm just going to pop it in here that we're returning the head. Okay, so same process. I first of all get a pointer that will point me to the current node so that I can travel through my list to find where it is I'm going to insert something. And then I'm going to create a new team pointer where I'm going to put in whatever it is that I'm going to insert. So I'm going to use my create team. I'm going to use my create team function, and I'm sending it the country and the number of goals. And I'm going to give it a null because I just want a basic pointer as well. Okay, so that creates for me an empty box with Madagascar, and now I want to find where to insert it, and I want to be able to actually insert it in. Okay, so this is going to be my condition in here that's going to be quite interesting. So what do we think is going to, what do you think would be the condition that I want to be looping with? Okay, so I mean, okay, let's just, actually, it's not really, the current is not equal to null because I want to go to the end of the list. Then really, what's going to be my decision point? Brendan, line 97 and 98 in simplified terms are creating the node with the following set of lines creating the position for the node. So Brendan, what's happening? Line 97 is not creating anything. Line 98 is literally copying whatever address is in the head to the pointer that's current. And that's because I don't want to touch the head. I don't want to lose where my head is currently because if I start changing where the head is, I'm going to lose the address that was in the head originally. So I'm storing it inside the current pointer, that same address, so that I can move through my linked list. Okay, and then this is the one that's creating the new node, and it's creating the new node with the information that I sent it in the main. Gordon, good question. Keep it without spaces for style. And Lisa said we're going to try an if and a string compare, and we are comparing two strings. Okay, so the first string is going to be current. You're going the opposite way, so which way should I go? I don't know. Oh, so you want to compare it to country, so whatever was sent to us. So this is the new one. This one here, if we're going to compare this way, this is the new one. And we're going to compare it to whatever is sitting inside the current country. Yeah? So that means that the current is going to keep going, and I'm going to keep comparing, keep comparing. Okay, and we can try it out. We can see what it actually does, okay? Okay, so if that is less than 0, you're saying we are going to insert. Okay, so what happens here? We need to do some inserting. So if it's equal to less than 0, and we can see what it does because it's not quite all there. So I'll do the same, it's really the same lines as before. I'm going to point my new team next to whatever was in the current next. And I'm going to take the current next and point it to my new node that I'm inserting. So new team. Okay, and then I return the head. So let's see what it does, and then we can tweak it. And this is the best thing about it. You know, it doesn't matter if you make a mistake, you're going to see what's going on. You're going to see that mistake as you make it, because it's going to insert at the wrong place. So you're going to see if you need to have stopped a little bit beforehand or a little bit afterhand. Okay, nothing has happened, which means that I forgot to do anything. Or I forgot to print out my list. Yes, so I forgot to print out after I inserted it alphabetically. So let's print out my teams, and I'm going to give it the head to print out so we can see if I'm doing the right thing or not. Okay, let's compile it again, and let's run it again, and let's see what it's done. Oh, what has it done? So it's printed, and it's inserted Madagascar after Uruguay. Ha. And why did it do that? What do we reckon? So it's inserted it in the wrong position. It's inserted it after Uruguay. So let's come back to our code and we can see why it has done that. And there is a reason for it. Okay, so let's have a look here. So we're comparing country and the current country. So I'm comparing Madagascar to Argentina. I'm comparing Australia. I'm comparing, oh, a few people have ideas. Let me have a look. For the string, how does the program know that country in line 101 is Madagascar? Okay, it knows it because I created it here. So when I created this new team, pointer, I sent it the country Madagascar to fill in. And we're using our create team function that we wrote over here, which actually puts it in here. So it string copies whatever the country is in there. Okay, then the next question was, and string compare with note after returns greater than 0. I'm not sure what Caitlin is asking. It looks like it was part of another question. When we have to end the while loop after we have inserted once, potentially, yes. Yeah, otherwise it will keep going. It will keep inserting it. So what can we do? We could increase this condition. So we could say whilst it's not equal to null, and also whilst this string compare then we want to do a whole bunch of things, and then we're going to, oh, now I've gotten a terrible indentation, I'm sorry, and it's hard to fix it because no, that's completely wrong. I'm just going to make this a little bit bigger because the indentation is really annoying me. That's bad style right there. There we go, that's a bit better. Okay, so this still doesn't feel very right, what I've just done here. This still feels a bit wrong. So let's have a look. So someone's suggesting to add a find condition. Someone's suggesting, does it need to be like the goal of last lecture? I mean, potentially, but potentially not. So what do you want to do? Let's have a think about what we actually want to do, and I'm going to write it here in the notes. Okay, so how do I know where I want to, actually insert it? So the way that it works is that I want to insert it when the current, so whatever is sitting in here, so let's say I'm comparing Argentina and Madagascar. What's it going to return to me? Oh, I'm going the opposite way, I'm sorry. What's this going to return, this string compare? Good pickup. So if I'm comparing this one, the M is greater than the A, which means that it's going to return, yeah, that's right. So it's going to return greater than 0. Okay, fantastic. Okay. Then what happens when I compare Madagascar and Australia? The M is still going to be greater than A, isn't it? So I'm going to return greater than 0 again. Okay. Okay, let's say then I'm going to compare Madagascar and what was next? Brazil. Okay. The M is still greater than B, which means that I'll still return a greater than 0. Okay, then I'm going to compare Madagascar and France, and the M is still greater than the F, which means that once again I'm going to return a greater than 0. And so when I do the next comparison, oh, who knew that Madagascar is so hard to spell? So then when I do Madagascar and Uruguay, finally, it's going to turn around, but that means that I'm going to insert after it, doesn't it? So can you see the mistake now? Yeah, exactly. So Sienna's pointed it out. So I really need to be comparing it not to the current one, but to the next one after it, okay? Because that will give me what the next one is. It will give me the insertion point. So if the next one is going to be less than 0, then that means that I need to insert at the current one. Does that make sense? So here, when I'm comparing, I actually should be comparing it to the next thing on the list because I'm inserting at the current point. So now if I save it and I run it, it's going to not insert it at all, because what have I done? What have I done here? Have I printed it? Insert alphabetical, print teams. Then I'm going to string compare. If it returns that for the country and current next country, then I'm going to say new team next is going to be current next is equal to new team next, and while loop condition is the wrong way. Yes, so the current is not incrementing. Okay, let's return it back to the if statement. Why not? Because I really want to move on as well. I don't want to spend too long debugging it. But you see how once we wrote it out, it became obvious why things were not working. So sometimes it's a really good idea to just write out what's going on. Okay, that should do it. Okay, extra bracket. That's an easy one to fix. Save that. And let's run it. And something is going to go down. So down. It's not even stopping. And okay, it does not love it. Okay, so why doesn't it love it? I'm not loving it right now. Let's check. If string compare country to current next country is less than 0, then I want to say new team next is equal to current next is equal to new team current is equal to current next. Okay, and what's it telling me? It's telling me that have I gone the wrong way? I think I've mentioned this before. I really hate greater than and less than symbols. They really take all of my cognitive load away every time I think, which way does the crocodile face? No. The symbol was the right way because it's got to be this way. That symbol was the right way. Yeah. Yeah. I do need both of the statements. Which both statements? Okay, let's just do it again with my and. I'm struggling with the if for some reason. Okay, let's do if current is not equal to null and string compare country current next is that should be, is that enough? Yeah. Then I'm going to say, okay, this is what the problem is. Okay, I can see it now. Okay, this is incorrect. So what I want to do, I want to keep moving across whilst this is true. And then when I'm done here, so when this condition is true, that's when I want to insert. Okay, the indentation is right off because now I'm just pasting anywhere. Okay, let's try this. A few errors because the indentation is completely off. I've got too many brackets. This is fun, isn't it? Okay. Here we go. Here we go. This is the moment of truth. Yes. Yes. but in completely the wrong place. Yeah, that's right. It is. It's because, yeah. So what's happening? And it's because I'm checking here, I'm moving it along. So whilst it's like this, I want to move it along. Otherwise, I want to stop and I want to actually insert it in. Okay, this is it. This is the final one. Yes, finally. We've got it. We've got it. What a success. Okay, so what we're doing in here is we're checking each time that the current is not at null, so we haven't come to the end of the list, and I'm comparing that it's greater than 0. So every time it's greater than 0, I'm going to move it along, okay? So once it comes out of this while loop, I know that the current next country is going to be the opposite way, alphabetically, which means that that's when I'm going to do my insertion. So I'm using my while loop to move it along in the list to where I need to insert it. And then when I come out of that, that's when I actually do the insertion and then I return the head. Okay, you can pop your questions in the chat. What we'll do now is we'll take a 5-minute break now because it's a good time to take a break before we start deleting. So someone's asked, okay, wouldn't it break if the thing was in the last one? Okay, I can't think of any country that starts with a Z. So I'm just gonna, oh no, I can. There we go. I'll insert something at the last point in time and you can see what it does. Aha, very good. Well done. It will break when you insert it into the last point. Well done. And why is that? How did I initialize the head? Like how did you assign head to the start of the linked list? Okay, we did that in our main function. When we were creating the team, we were saying what the head is, and then I keep passing the head to all the functions that I do. So that was a really good question from Farron, because very good. That's right, because current next country will be null. Excellent. So that is one of those boundary conditions that we want to be looking out for. So how could we control that? So we could control it. I think someone said we could do current next is not equal to null, which will not let us get to a null. So you can see what that does, and you can see then how the boundary conditions work, and it's really good to play around with them. So you see, this is one time where we could have searched for a current next to not break it, because what it's doing now is it's searching that inside this next is not a null. So if current next is not equal to null, and my comparison is also not equal, then I'm going to move along. But once I see this null here, I'm not going to move past it. So this is one place where it would be useful to have this to counteract that last section. Or you can have an if statement after the while loop to catch out that boundary condition as well. Can it also insert at the head of the list? That is an excellent question. So it's going to struggle at the head of the list. You need to have a boundary condition. Because what's going to happen is you're going to lose your original head. So you need to redo your head. So you would have an if statement to check if it's the first thing that happens. So you would have an if statement here at the very beginning to see if it's in fact the first thing that you need to insert. And that if statement would catch out if it's the first node. So before you do your normal alphabetical thing, you would check it here. Is it the first thing that I need to insert? And you would take care of it first. So it's one of the boundary conditions that you would think of first. Excellent question. All right, 5-minute break. We'll come back at 1 o'clock and then we will do some deletion, which will be also like similar stuff like that. But please, this is going to be quite useful to you for your assignment. So play around with it. Use the code and break it. Play around with what on earth it's doing. Separate it out. Think of already you have thought of so many different boundary conditions, which is really fantastic. And we're going to think of a few more now in 5 minutes that will delete our nodes for us. So let me switch out so that we can have a 5-minute break. Hello everyone, welcome back. It's been 5-6 minutes. There was some amazing calculations in there. Yep, it is not 24 and it is 22. Well done. That was pretty good. Okay, and I'll just also let you know that question was on the Google Interviews question. So yeah, for a software engineering job. Anyway, just beside the point, but apparently it's floating around the internet. Okay, let's get to the deletion. Okay, so where can we delete things? We can delete things in many places. Let me go up to our numbers list again. Let's start with numbers deleting because I think it's easier to understand when we delete numbers before we go on to delete. If we have time, hopefully, we can delete some of these as well. But I mean, it's going to operate on the same principles. Delete is delete. Okay, let me scroll back up towards our lovely... Okay, here was our numbers. And what I'll do is I might delete all of these and then we'll talk about and yeah, I see people, so we'll talk more in detail about the exam in week 10. So don't worry, it will come, we will talk about it. We'll show you what it looks like. We will prepare you for it. Don't worry, it's happening. I've written some of the questions. I hope that they are easy to understand. Okay, let's do it. Oh, hang on. I'm not showing you what's going on. That's unhelpful. What's the average exam marks? Oh, that's a very difficult question because the average exam marks depends on the cohort. But usually questions 1 to 4, the programming ones, are done quite well. And they're the hurdle questions. So they're the ones that are worth the most as well. Question 5, hopefully you'll attempt as well. But we'll talk about it in week 10. So don't worry, we will discuss it. We will discuss it in great detail, in fact. Yes, absolutely. So there is going to be this situation where we're going to insert or delete at the head and it's a special condition, okay? We're going to take care of it now in the deletion. And then I want you to think about it for insertion because you're going to have an if statement to deal with it in insertion. So I'm going to leave that as a thought, but that's well done. Let me just... Okay, so where can we delete? There's really a few places. So I could delete my head node, yeah, which as we've said is going to cause some problems because if I delete this head node, then what I want is, okay, so we're going to delete, we can delete the head node and my pen stopped working. So we can delete this head node here. Or we can delete one that's in the middle of 2 nodes. Or we could delete the tail, okay? What are some other special conditions that you can think of? So currently I'm showing you a list with 3 things in it, okay? What are some other lists that you think might cause problems? What do you think are some other special cases that we might encounter? Okay, can anyone think of a special case? What if I ask you to delete from a list that has nothing in it? What do you reckon of that? That's going to be a bit of a disaster. Yeah, Sienna's got another one. If there's only one item in the list, because then I need to really delete the entire list at that point. So I can delete the first node, or I can delete the node in the middle, or I can delete the last node. Now, some boundary cases are, if there is an empty list, that's going to cause me some problems, okay? If there's only one item in the list, that's going to cause me some problems. And I need to be able to take care of all of these sorts of boundary cases. And it's the same for insertion. So someone's pointed out in the insertion, we are going to have that problem if we're inserting at the head. But that's why we wrote that function first that inserts at the head, because that changes the head position each time. So we really need to check where it is we're inserting. If we're inserting alphabetically, check if it's at the head of the list, because then you'll change the head of the list. Okay, so let's say, which one should we go first? Which one should we delete first? Well, the really easy one to do, I suppose, if there's nothing in the list to delete. If there's nothing to delete, then I'm obviously not going to do anything. So let me do a function for a delete. Okay, what do we think we need? Oh, I'm in the wrong file. Let's go to here. Okay, what do we think our delete node is going to be? Okay, I've even done the stub for it. So convenient. Okay, inside linkedlist.c in the week 8 lecture code. Okay, what do we think we need to return when we delete a node? And what are we sending to our delete node? What are we going to give our delete node function when we want to delete something? Okay, what do we reckon will be the inputs and outputs here? Yeah, so Sienna, the team, yes, output head. So we're going to output the head again. So I'm back on the nodes, not the teams. So struct node, delete node, and we're going to give it country and next. Yes, but except I'm going to give it not country and next, but I'm going to give it. So I'm back to the number nodes now, because it's easier to demonstrate first with the number nodes before we go back to that example with the chars. And what am I going to delete in here? I'm going to give it the head of the list, or I'm going to give it what I want to delete. So I want to delete some sort of data, and I'm going to give it the head of the list that it needs to go through where I'm going to delete. Struct node head. Okay. So I'm going to give it two things. What I wanted to delete and where I want to, the list where I want to do the deletion. Okay, so what I'll do is I'm going to take this function and I'm also going to copy it into my header file so that it's available to my .c file. So I'll pop it in here and put a semicolon even. I'll remember to do that. And let's go back to linked list.c. Okay, so let's do, let's do the very first thing. Okay, so let's say I've got a list with nothing in it, okay? So that's one of my boundary conditions. If there is nothing in the list, how do you think I would check for it? And before that, what I really want to do, and what I do really any time that I play around with lists, is I want to set my current to the head of the list, because that's the one that's going to be always modified. So my current node, to keep track of where I am. So what I'll do is I'll do that first. I'll create my current pointer. So struct node current, and I'm going to point it to the head. Okay. So now, if my first boundary condition that I'm going to check for, what if there's nothing in the list? What is my current going to be equal to? So Lisa, if current next is equal to null, that means the list has one item in it. It has a current in it. So if current next, then what you are saying is, let's say there's a number in there, and this is my next, and my next is going to be a null. But what that means is I have one node at least, okay? But if I have nothing in the list, then my current is just equal to null, because there's nothing there at all, okay? So if my current is equal to null, then what that means is I've got nothing in that list. So I really can't do much, and I'm going to return a null, because there's nothing I can return I'm going to return, and I need to return a pointer, I've said. So I can't return 0, but I can have a null pointer, which is why I'm returning a null in here. Okay, then there's this extra semicolon that I do not want. Okay, so what that means next, okay, is I have another condition, okay? If the item we want to delete is at the head of the list, or if there's only one item in the list, therefore deleting at the head of the list, okay? So in that condition, I'm going to have a list that looks like this. So this is my head, and I've got some sort of address in here. And this is now null. So whatever happens, I'm deleting either just one thing, or I'm deleting the head of the list. I'm deleting this one here if I have a few items in this list. Okay, so how do I check that the first item I've delete is going to be at the head? Well, first of all, I'm going to, when I delete a node, I want to delete a specific node. So I'll go back up to my main. Oh, I'm in the wrong file, okay. So if we're deleting a node, let's say I'm going to call delete node, and I'm going to give it an int data, and I'm going to say this, okay. So what that means is, nope, I want to delete a 1, because that's going to be the first thing that I'm going to delete. Okay, so I'm deleting a 1, which means that the 1 is going to be my head node. Okay, so I need to check whether the data in my node at the head is equal to the one that I want to delete. Okay, and I'm telling it which one I'm deleting. So I'm going to check, is this equal to 1? Because that's the number that I want to delete. And if it is, that means I'm deleting at the head. So if my current data, so that's how I access the 1, if it's equal to the data that I've told it to delete, so if it's equal to this data that I've given it, okay, then that means I'm at the head and I need to have a new head. So in that case, to compare it, if my current data, and remember that I'm still at the head, I haven't started moving yet, so my current is still at the head. So if my current data is equal to the data that I've asked it to delete, then that means I'm at the head and I'm going to need a new head, okay? Because if I delete this node now, okay, if I free it up, my head is going to point to nothing. But what will happen is if I'm deleting at the head, my new head pointer has to point to whatever was sitting in my current next, okay? So it has to point to my current next because my new head is going to be the next item in the list, okay? So let's have a look. So if I match the very first thing, that means I want the first item in the list to be deleted, then I'm going to make a new head. Okay, and the new head is going to take whatever is in current next. Okay, and what that means is that I'm looking at whatever is sitting in this address over here, this current next, so this box here. So what I'm saying now, my new head is going to be pointing to this one as the start. Okay, so I'm going to point the new head at the start, but now what do I need to do? This node is now floating in midair, okay? So I still have this node, it hasn't been deleted. All I've done is I've said, I've got a new head. And the address of this new head is 0b33. So this is my new head now. This is now floating around. I want to get rid of it. How do I get rid of it? What do you guys think? What goes well with malloc that releases what we've mallocked? Yeah, free the memory. Well done. So that means what I'm going to do is I'm going to free the current node. Because remember, I'm still sitting on the current over here. So I'm going to free the current now that I've got a new head. Okay, so I'm going to free the current. Okay, and then what do you think I'm going to return in this case? I can't return the head because the head is pointing to this current that I've just freed. So what do you think I'll be returning? What do we think I'll be returning? Yeah, well done. I'll be returning my new head. Or even head, not Jed. Okay, so that's taken care of this condition if I'm at the head of the list, okay? That means I've deleted the first item, and what I've done is I've given it a new head. And what you'll notice, if I only had one item in the list, it will also take care of that, because my next value is null. So my new head is just going to be equal to null. It's going to be pointing to nothing, and I'm going to delete this situation here, full stop. Okay, excellent. We've now taken care of that case. Okay, what should we do now? Otherwise, if it's not at the head and if it's not an empty list, then it could be somewhere inside my list that I need to delete. Okay, so I need to loop through my list and I need to delete when I find the right node. Okay, so how will we do that? Let's have a look at deleting, because it has a slightly specific, there's a few ways to do it, depends what you prefer, but let me just get rid of these so that you can see what I'm doing. Okay, let's say I now want to delete, I don't know, I now want to delete this node here with the number 2 on it. Okay, so if I want to delete the one with number 2 on it, I'll have a current here, and what will I do? Okay, I might go over here. So I'll go to here and I'll say, okay, this is the node that I want to delete, okay? And if I want to delete this node, then what should I do? So this node here would need to point to the one after it. So it would need to point to whatever is sitting in here. And what else needs to happen? Does anything else need to happen? Yeah, oh yeah, sorry, I didn't see Sienna's question. Yeah, we don't need a new node because we're deleting nodes now. We're going crazy, we're removing them now from the list. But we're just fixing up where we're linking things to when we remove it, and we free it with the free function because that allows us to clear out the memory space as well. Okay, so let's say we're deleting this 2 node. So what will happen if I then say, okay, I'm going to then say in here, this is my current node now. So I want, how do I say I want my previous node to this current one to point to the next one after it? That's going to be quite hard to do, isn't it? Yeah, so the pointer of the one before being deleted needs to point to the one after being deleted. That's right. So that's very good. So the pointer of this one that comes before it now needs to point to this one over here. And then we free this one. But if my current is sitting on the node that I want to delete, that actually becomes quite difficult because I don't know what came prior to it. Yeah? Unless I've seen people sometimes keep track of a previous one. We don't usually do that in 1511, but I mean, you can if you want to. But what's another way to do it? Well, I can always search whether the current next, so I can say current next data, which will access this one, is it equal to 2? And that means I'm not moving my current, I'll still be over here on the current. But if my current next data is equal to 2, then that's the node that I want to delete. Yeah, exactly. So Lisa's got it. So that means I can now say, all right, fantastic, it is equal to 2. That means I want to delete this node. So what I'll do now is my current next is going to be equal to the current next, okay? Because it's going to be equal to the current next, which is going to be this one. And then I'll go next again, which will bring me to this one. So what that means is I'll now be pointing from my current to this one. And that means that I'm ready to delete. Then I can say I want to delete whatever is sitting in my current next, and let's see it in code. Okay, and we'll see if that gives us the whole picture. Okay, let's have a look. Otherwise, so we've got our two boundary conditions. Otherwise, start looping through the list to find the data. Okay, so find the previous node to the one that you want to delete. Okay, and we've kind of talked about that. So if my current next data, oh, I forgot an arrow. I do that often. If my current next data, and if I want to make it a loop as opposed to an if statement, so it's fine to have an if statement as well, so I can loop across until I have an if statement, or I can say whilst it's not equal to data, which means, you know, keep traveling through whilst it's not equal to, no problem. So, but what else should I be checking? What else should I be checking? So I'm checking whether it's, you know, equal to the data, but what else should I be checking? What could be a problem? Because I'm not just checking the current one, I'm checking the current next one. So what could be a problem? Yeah, well done. So I could easily run into the problem where I'm sitting over here and I'm accessing the null pointer because my current next data is actually null. Okay, so I need to consider that in my while loop. So whilst it's not equal to that, and whilst my current next, and which one do I want to do it for? Current next or current next? So if I'm currently here, remember that I'm going to be linking it to the current next one over. So that means I want to check that that next one over is not equal to null, because otherwise I'm going to be in big trouble. I'm going to be linking it to nothing in particular. Okay, so that will take care to mean that I can link it, that I have something to link it to, but also that I might be able to find my number. Okay, so what happens then? So if those are not equal, then I'm just going to move myself along. So I'm going to increment in my while loop. What that means is when I exit this while loop, then I'm definitely going to be at the node where the next one needs to be deleted. Because these conditions are not true, that means when I exit the while loop, they are true, okay? So because I have two conditions in here, either this one is not true or this one is not true, okay? And I need to check that I have a potential. So what I'm going to do is I'm going to check which condition is it. So if my current next data is equal to the data, then what I will do is I will delete it, because that means that I've got my whole situation, everything is working okay for me. So I'm going to create a struct node pointer to a new next, okay, because I'm going to connect it up over to. So what will happen is, okay, I want my new next to be equal to this one here. So I want it to go a few over. Now, when I delete this one, what's going to happen is I'll need to incorporate that address in my node prior to the one that I've deleted. So my new next is going to be current next. Okay. What that means is it's going to be current. I'm currently sitting over here. So current next is in here. I access it, go to this one. And then the second next, I access this and I go to this one. So what it means now is that my new next pointer is going to be equal to the address of this node here. So it's going to be the address of that pointer there. Okay, and someone's asked, why can't current next be null? Okay, if current next is null, current next is null, that means I have reached the end of the list. So it could actually be equal to null. Yes, it could be. I thought I was, I'm sorry, in my practice I deleted the node after it. So, oh, hang on. Yeah, it could be equal to null in this case. Okay, so then we free the node that is to be deleted. So we're going to free my current next. So I'm freeing this node here. I'm getting rid of it. So free the current next. And I'm going to point the next node to the new pointer. So my current next now goes to this new next, which means that this node here is now going to point to there. And then I'm going to return the head. Okay, let's see it in action. Let's see what it does and if it actually does what we want it to. Okay, should we delete at the head first? Or should we do, let's do a 2 first. Okay, DCC main.c linked list.c. Oh God, what have I done? Oh, I'm in week 7. Okay, don't worry, I haven't done anything. There we go. Let's try this again in the right directory. Okay, that feels a lot better. Okay, and if we run it, so my linked list 1, 2, 4 inserted a 5, inserted this, and then I want to delete a 2, and it deletes a 2. Okay, let's see if it can delete at the head where we put in a boundary condition for it. So now if I try and delete a 1, which is going to be the head, let's see if it's going to be able to print out the right thing for me. Oh, goodness gracious, it does not. Okay, so what doesn't it like? So let's have a look. Aha, it doesn't like a malloc use after free. So what on earth does that mean? Yes, well done. Oh, fantastic. Someone's watching. Excellent. Yeah. So the head is still pointing when we delete this head node, okay? The head is still pointing to the old node because I've not changed it anywhere, okay? So what happens is I actually haven't changed anything at all, which means that the head is now pointing to a piece of memory that doesn't exist, okay? There's nothing there because I deleted that first node. So if I wanted to take care of that, I need to now make my new head, whatever this returns, because my delete node returns a new head, I'm going to place it into the head pointer. Okay, so let's try it again. And let's run it again. And this time, no problem, it will delete it. It will delete it nicely. Okay. How does everyone feel about the delete? And this is us just deleting one item, yeah? What happens if I want to delete my whole list? What if I want to free the whole list? What do you reckon then? How would you free the whole list? What do you reckon you would do? Yeah, so we would free the head, okay? If we free the head, which is not, incorrect, we do free the head, the other nodes that we have in there, so the nodes that we have malloced, are still kind of hanging around, but they're just not connected to anything, okay? So what do you reckon we could do to take care of that? What do you reckon we could do to make sure that there is not just, I don't know, random things hanging around, random bits of memory that are still used up? What do we reckon? Yep. Okay, well done. So we're going to traverse through the list and free all the nodes one by one, and then we're going to finish. Yes, well done. So we're going to traverse through the list and we're going to just free until we just free the lot of them. Okay, should we try writing it as a function? I think that could be fun. Let's try that. I mean, I don't know. Maybe it could be fun. I think it could be fun. Let's do it. Let's see. Maybe it's not going to be fun, but it has a lot of potential to be fun. Okay. Okay, I think, should we call it free list? That's a fun function name. Let's do that. Okay, so what will free list return for me? What do we think it's going to return if I had this function? And I'm going to put it right at the end here. If I'm deleting the whole list, I'm deleting the whole list. So what do you think if I free the whole list? What do you think it will be returned? What do you think will be returned if I'm, yes, excellent, void. I'm not returning anything. Yeah, because I'm just getting rid of everything. I've got nothing to return. And what will I give my function when I'm freeing the list? What do we think I give it? Well, I want to give it, I want to give it the head. So I want to give it what list I want deleted. Okay, so I'm going to give it a struct node. Oh, I've just started typing in the YouTube messages because I'm reading yours. So you almost just got a struct node pointer there. So struct node head. Excellent. Okay, so we're giving it all of this, and now we want to free the whole list. So what we want to do is we want to move through this list and we want to delete as we go. And we've said we want to free them node by node. Okay. So again, I'm going to have this lovely thing where I'm going to create a current pointer and I'm going to point it to the head of the list. And then I want to make my way through that list. And in this case, because I want to delete every single node, I want to make sure that I'm at the end of the list when I'm deleting. So I want to check whilst current is not equal to null, I'm going to keep going through it and I'm going to keep deleting things out. Okay. All right. So whilst current is not equal to null, okay, the problem is going to be I'm standing on current. Okay. I want to delete current, but I also need to know how to follow to the next one from current. Okay. Because if I first just start freeing the current, how to get to the next node. So that's going to be a little bit of a problem for me because I really need something to hold the value whilst I delete that lovely one there. Okay, so what am I going to do? I'm going to hold the value in a temporary storage pointer, basically. So struct node the free node is going to be my current because that will give me access to what's going on. Okay, then what do I want to do? So I've just put the node that I want to free, I've put it into the current. Okay. Then I'm going to, and there's more than one ways to do this as well. Okay. Then my current, I'm going to move it along to current next. Okay. But the address of this node that I want to get rid of is sitting inside free node. So I'm going to free my free node. And what that means is now I've gotten rid of it. Okay. And I have also moved along to the next one. And I don't need to return anything. So this is going to clear out the list. Now, there's, I could check for it, but I can't print anything out. I can't call this function, okay? So what happens is that if I call this function, I can't then call free because if I I can't then call print list because print list is going to have nothing in it. It's just going to be all deleted. There's no memory to it. There's no head. There's nothing. So I'm not going to really be able to do much with it. So you kind of have to trust me that this will work in some way or work in any way, just work. Yeah, so any questions so far on deleting from a list with numbers? Because then we can try deleting from a list with letters next. So we can try going back to our World Cup prep and playing around in there a little bit. Why do we put free node after current next? I mean, it doesn't have to be. It could go, they could be swapped positions, line 150 and 151. But usually, I mean, when I write code, I'll try and free as the last thing I do, because otherwise I'm always worried I'm going to free something that I need, which does happen a lot. And you will find that out when you do the assignment, just freeing things that, you know, you shouldn't have freed, or freeing things and then trying to access them afterwards, which is a big problem. But you'll see it straight away. It'll tell you that you're trying to access memory that doesn't exist. Any other questions so far? No, everyone happy to go to World Cup, or does anyone want to go over anything again? I know that it's not easy when you first see the linked list. I really do strongly suggest drawing the diagrams, especially when you start deleting, because you've got this situation where you've got next, or and those arrows with the next, they really they just do your head in sometimes. And remember, there are different ways to solve things. So a few places where I've worked at as well, they will have, so we define our, we define our linked list node by having a next in there and an int data. So some companies, some people will also have a struct node previous here as well. So they are always going to keep track of the previous node as well, which is quite interesting. It changes their code a little bit, but what it means is that deletion might be easier to do. And it depends on what you're doing with your code. So if you delete all the time, then you might keep track of the previous one. Or if you're doing something that requires the previous node all the time, then you'll keep track of it inside your struct. Ethan, does the free node free the head? Well, it frees them one by one. So what happens in here, in this piece of code, I've set the current to the head. So let me just erase these lines here, and I'll just draw it up again so then it's really easy to see what's going on. Okay, so oh, wrong way. Okay, so if we're trying to free all the nodes one by one, what we do is, again, I set my head to current, okay? And if we go through this piece of code here, line by line. So line 147 is where I've set this current to be at the head of the list, okay? The next one is the loop condition. So it's saying while current is not equal to null. So if current is equal to null, this is where it happens, where if current moves to over here, that means that I've gotten to the end of the list, okay? Okay, then what I do is I create a pointer, because I'm going to start deleting them one by one. I create this pointer called a free node, and what I do is I put the address of my current in there, because once I delete the current, I don't know where it is, okay? So I've put the address in there, so my free node pointer is now storing the address of the current in it, which is 0xFFA, and these are made up addresses just for demonstration purposes. Okay, then the next thing I say is current is equal to current next, which means that I'm going to move my current along. So the current is now over here. I am no longer here, so I'm now standing over here. And then I'm saying, okay, fantastic, I've moved my current here, and now what I want to do is I want to free this free node. Okay, so if I'm going to free this free node, what that means is I'm freeing the memory address that is inside the free node. Okay, the address that I'm freeing is this one here, which corresponds to this node. So I've just deleted it. So that node no longer exists. And at this point in time, I don't really care where the head or tail is because I'm not going to return anything from this function. I'm literally going to go through and delete one by one. Okay, and then my current, is it equal to null over here? No, it's not equal to null yet. So I'm going to go through this process again, delete, and then I'm going to move my current along to here. And I'm going to go through this process again and delete. So then it deletes this one. Then I'm going to delete this one. I'm going to move my current along. And when my current is sitting at null, this while condition is no longer true, which means I exit out of it. So what that means is I've now gotten rid of all the nodes that were in this linked list, which means that, which means that there is nothing there. I don't have a head, I don't have a tail, I don't have anything. The list is gone. Any memory associated with this list is now gone. Yeah, because the nodes is what I malloc the memory for. It's a good question. Any other questions? Did that make it more clear? All right, I'm gonna say yes because there is no questions in the chat, but I think I might be on an even bigger lag than 10 seconds right now. Hang on a second. So here in my delete node, I've just realized I said to you they could be swapped around, but in fact they cannot really be swapped around because if I'm standing on the current over here and I delete it, I can't really go to the current next. So it's going to be a bit of a problem for me there. So they have to come in this order. So I think Theo asked that question. So in this case, they have to go in this order. And when I drew the diagram, it kind of made me think twice about that statement. Theo, are we going to learn how to put linked lists in each node? No, we're not. I see what you're saying. You're saying to link them up together like a two-dimensional linked list. Like in the assignment. Is that what you're saying? I think that's what you mean. Okay, if that's what you mean, I haven't planned to do it yet, but we could do it. Yeah, okay, we could do it. But I'm going to struggle to think of something on the spot. What should we... Tom Killingback, can you think of an example on the spot that I can do to do that? Just putting you on the...
I can't think of anything off the top of my head.
Yeah, off the top of your head, what can I do to link up that makes sense in the context? Because that was a good question, I guess, too.
Yeah.
Oh, it was just a question. Maybe I'll do something, I'll prepare something for next week and go through it, because then it's going to make sense contextually, because I didn't think of doing that today. I thought the deletion would take a lot longer, but everyone seems to be like, yeah, deleting, no problem. So that's great. Okay, I'll think of a context that makes sense. Okay, should we try and delete a node in here, in our beautiful character situation? I'm going free code now as well. I haven't prepared this part either. We've gone further ahead than I thought we would. You are just all amazing. Okay, let's delete something in here. Okay, let's delete a particular item. Maybe we could do a pizza place. That's a good idea. Okay, let's do a delete function. So let's delete team. And if we delete a team, I'm going to return a struct team. So I'm going to return the head. And when I delete something, I'm going to give it a country to delete. Actually, there is something I wanted to point out that is in the assignment just to make sure that you are comfortable with it. So I might do that too. I might do it now quickly. Okay, so you might have noticed in the assignment, if you have looked at the assignment, that it uses, your functions actually use, so we're using an array of char, and their functions in the assignment look something like this for our arrays. I don't know if you've noticed. So you're passing the pointer as opposed to just this full thing. However, in your struct team or in your struct, whatever it is, pizzeria, it's still going to have this array here, but you can be passing a pointer. And if you remember, it's because when you're passing a pointer, char star, it's taking you to the first index of the array, which is why you can do that. Okay, so let's delete oh God, now I've done this. Now I've got to change it everywhere just so that you can see it does work. I'm not crazy. So I'll just delete it there just to show you that that is something else that you can do, and that's what your assignment does as well. But it will be up to you how you feel things up as well. But just in case that you know that is still doing the same thing really. Okay, so where were we? Deleting the team. Let's delete a team and we will tell it what to delete. So I'll go to the bottom. I'll do it here. Okay, and we're going to delete a particular team. So once it matches out. Okay, so we've got a few potential situations, don't we? So let's say, let me go back up to okay, here was our list with the different places. Let's say we want to delete Brazil. Okay, let's say we want to delete Brazil. So I'm going to call this delete team function. And I'm going to give it Brazil. I don't really need to give it the goals, do I? That was an extra that I do not need to give it. I just really need to give it the country that I want to delete and the head of the list that I want to delete from. Okay, so here we are. Okay, so let's say we want to delete that Brazil. What are we going to do to be able to do that? Okay, we're going to do, I think you're all getting bored of me saying a very similar thing. What are we going to do here? Okay. Well, I want to have a current set to the head of my list because I'm going to comb through that list and I'm going to find what I want to delete. Now, if you remember, deleting was pretty fun because if I want to delete this Brazil, then I want to be changing, what do I want to be changing? I want to be changing the previous one to the one that I want to delete to the next one after I want to delete. So I want this to go to this now, which means that I should really be searching for current next data because then that means that my current will still be at the node where I am at, and that will make it a lot easier for me. Yeah, so all this code is available on the World Cup one is in the week 7 folder. Okay, so let's do that. Let's go through that and we'll do that. So, okay, I'll do the easiest case first, okay? So, but there are going to be boundary conditions that I'm not touching yet. So I'm just going to do the easiest case first. And I've done it because I'm deleting Brazil. So Brazil is kind of in the middle of the nodes. It's probably the easiest way that you can delete a node by doing it like that. So struct node current is equal to the head. So what I've just created is I've created this current thing here where I'm pointing to the head of the list. Okay, so now I want to travel through until I find a place where my current next country is going to be equal to the country that I've given it here. So I want to be able to be moving along this list. So whilst it's not equal to, I want to be able to move across the list. And then when it is equal to, that's when I want to stop, and that's when I want to do my deletion. Okay, so whilst my current next country is not equal to the country that I've given it, so whilst it's not equal to this country that I have given it, I'm going to just increment to the next one. So current is equal to current next. Okay, what do I need to consider here? What should I consider here? And because I'm searching current next country, so what should I be considering here inside my while loop? So I'm moving my current to current next, and whilst it's not equal to the country, I'll keep going. But what happens if my current next country, so if I'm standing here and my next, and I'll go here and there's going to be nothing there, it's going to be null. So what's going to happen is I'm going to access a null pointer, which is not really going to be very nice for me. So I really want to counteract that. We will use a string to compare. We will. Don't worry, we will. And I can use it in here. I'm just moving it along. Oh, yes, I should be using a string compare here. My goodness. Yeah. So whilst my string compare is not equal to country, is not equal to 0. So whilst they're not equal, my goodness. Yes, absolutely. Good pickup. And shouldn't it be struct team? Yes, yes. This is what happens when you go between nodes and teams. Well done. Good pickup. And Lisa, we absolutely should be using string compare. It's because I'm still on the nodes. That's why I'm comparing numbers, not strings, in my head. Okay, fantastic. So those were excellent pickups. My goodness, everyone is so awake. It's just amazing. Okay, so while string compare, current next country, and country is not equal to 0. So whilst my current next, so whilst the country in here is not equal to the country that I want to delete, so whilst they do not match, I'm going to keep moving across. But I also need to make sure that I have something to access, don't I? So I also need to make sure that it's not equal to null. So whilst current next is not equal to null, okay, and we can see if perhaps this is the wrong thing to do, but we can check once we run the piece of code, because there could be perhaps something in there that's not what I want to do, okay. So when I come out of here, I want to know, it could be two things. Either my string compare is equal to 0, or my current next is equal to null. So that means I want to check, because I only want to delete the nodes if this is in fact true. So if string compare is equal to 0, that means the two strings have matched up. So if it's equal to 0, and that's why I exited out of that while loop, then that means that I want to delete that node. Well, the node after it, really. So if it's equal to, then I'm going to make a new node to, no, again with the nodes. Struct team, okay, and it's going to be a new next. And what I'm going to do is I'm going to put the address of my current next into it so that I don't lose it when I free my node, okay? So I'm going to pop into it. So if I'm standing over here right now and I want to delete, now I'm standing over here on my current and I want to delete Brazil, then what do I want to do? I want to save whatever is standing. So I want my current pointer to be pointing to the one after the current, and I'm going to delete the current next. Okay, so I'm going to be freeing the current next, so I'm just going to pop that in there. And then we just pick the orders. Okay. So I'm going to delete this current next, and I want my current one to be pointing to, no, I want my current next. So whatever is the current, the next one, I want it to be this one over here. So the one after it. So the one that was in current next, next. So that means I want to retain this current next in here. And that means that I'm going to set my current next to the new next. Yeah, so current next. Well done, well done. Okay, so what that will do is that will delete the node with Brazil, and it will point my current node to the current next, so the one after. And it will allow me to just get rid of this node really, and then I can return the head. And again, we haven't dealt with the situation where I might request to delete in the head, but if we were to run this, okay, let's see, I've aha, there we go. I forgot to finish this out. Okay, return, and I'm going to print the teams afterwards as well. Okay, let's save it. Let's run it again. And let's run it. Okay, so first lot, this is what happens when you just keep piling it in. That just printed out the list. Then we printed out the list again. And then with the insertion of Zimbabwe, and then we deleted Brazil. So as you can see, Brazil is now missing. So now we've printed out the deletion part. And what happens if I did ask to be deleting at the head? Well, it's exactly the same as with our nodes. You need to check if whatever I want to delete is actually located in the head, okay? So I would need to check here also if there's nothing in that list. What if that list was empty? So if I want to check if that list is empty, I'm going to see if current is equal to null. Because if current is equal to null, that means that there is nothing in that list to delete, okay? So that means that I would just return a null pointer because there is nothing there to delete. So this is a boundary condition if there is nothing in the list. And we always check for this one in particular. And then the other boundary is going to be if the match to delete is in the head, as someone has said before, because that's another boundary that we want to always be taking care of, okay? So the other possibility that we have is if let's see. So if we are actually in the head that we are deleting. So if my current country is equal to country, that means I'm deleting the first node, okay? So if I'm deleting the first node, well, that's going to be another boundary condition that I need to take care of. Okay, so in that case, what I'll do is I need to give it a new head. So I'll have a struct team. Reach run. Nailed it. Thank you. Thank you for picking that up. Then we'd have struct team, and I'll have a new head for this list. And I'm going to set it to the current next, okay? Which means that I'm either setting it to null or I'm setting it to the next item in the list. Okay. And then what that means is I can free my current, and I'm going to return the new head. Because what that will give me is the address of the next pointer now. And that will take care of two boundary conditions, just those few simple little lines of code. But then if you remember what happened when we were just doing it with the plain list, if we run it now, it's not really going to work because we haven't reset our head. So I would need to actually make the head equal to whatever the delete team returns and then print it out, okay? And if I'm deleting the first thing, so Argentina, let's hope I spelt it correctly, and I'll run it. I'll run it quickly, and then it will be time to finish up. Run it, and something has gone wrong. I should have run it beforehand, and it was inside my condition. Oh, because I prepared you for it, and then I didn't run it. Okay, so it's saying here, look at this, values when execution stopped. My country was Argentina, but my current next was null. So what happened there? And if you can see here, I'm accessing a field with a null pointer. And it's happening inside this while loop. Okay, so I'm going to let you guys think about it, and we will answer the question next week because we have run out of time. But I'm going to say that we are done for today because we are done for today. I think I've tortured you enough with next, and next. I hope it's all becoming clear. There's going to be a lot more that we're going to do about it in the labs as well. And we're going to talk about it a little bit more as well next week. In fact, if you wanted to do a little bit more linked lists next week, what I'll get you to do is I'll get you to just pop it on the feedback for me. Yeah, cliffhanger. I love going for a cliffhanger. So just pop it in there. If you want to spend some more time on linked lists, I can do that. I've kind of left a little bit of time. And if you wanted to look at anything in particular with linked lists, so like Thea suggested we do, connecting a linked list for another linked list, we can do that as well. And I think I will do that. And I saw towards the end, Thomas suggested we could do connecting suburbs in, which is so exciting. So we'll do that next week so you can see how a two-dimensional list works, and then we'll kind of take it from there. So thank you all so much for tuning in. I know linked lists can get quite, a bit of a brain fuzzle with all the next arrows, but hopefully draw it out and see what's going on. And the more you do them, the more you can see what's happening, and the more you kind of get a feel for what needs to go where and what needs to point where. And I hope it's really making pointers feel more obvious to you why we have the pointers. So thanks again for tuning in. I'll see you all next week. Have a wonderful week ahead. Don't forget we're running an assignment live stream tomorrow at 6 o'clock. So please tune in to help you get started on the assignment as well. The earlier you start, the more help you can get. All right, thanks all. See you later.